Hello everyone, today let's solve the problem number 55, jump game. So what the question states here, we are given an integer array nums and we start at index 0. Here we'll start at index 0. Each element in the nums represents the maximum jump length at that position. Here you can clearly see this represents the maximum jump length means 2, this 3, this one 1, this one 1 and this one 4, right? So each element in the nums represents the maximum jump length at that position. Our task is to determine if we can reach the last index or not, right? So what is our main task? Our task is to determine if we can reach the last index or not. From 2 to 4 we can reach or not. Here in this example from 3 to 4 we can reach or not. Let's see the same thing. Let's consider example 1. So let's consider the example 1 and example 2. Here you can clearly see one thing. We have 2. So we can move 2 steps, right? At a time 2 steps or 1 step. So here either I can move 1 step at a time from here to here, or either I can move 2 steps. So let's move 1 step to here, right? So next we are here. We can either move 1 step or we can either move 2 steps or we can either move 3 steps, because here the number represents the maximum step length, right? So here we will move from here to here. So we can reach the last index here, right? So we can reach the last index here. So the output we have to return in this case is true. I hope this is completely clear, right? So the second example here is 32104 they have given. So first, if we move 3 steps also here, suppose if we move 2 steps, then we have to move 1 step, then we have to move 2 steps. So it will be 0. Then here if we move 2 steps instead of 1, then we have to move 1 step, then also we'll end up at 0, right? Directly if we move 3 steps, then also we will end up at 0. We cannot reach the last index at all. We cannot reach the last index at all here. In this case, we cannot reach the last index at all for the second example 32104. In this case, what we will do, we will return false, right? I hope this is clear. So this is what the question basically states, right? I hope the question is completely clear. Next, let's discuss the approach step by step, right? So I'll just come here. We are going with the greedy approach, right? So we are going with the greedy approach. Just keep this in mind. We are going with the greedy approach. I hope this is clear, right? This is one thing, and we are going with the first example here. The first example that they have given in the question. This one itself I am considering here. 23114. So the output we need here is true, right? So we saw this one already. We have discussed this one. So let's discuss the step-by-step execution. Means we are traversing from right to left. Nothing but here reverse iteration. So we are doing reverse iteration here. We are traversing the numbers from right to left, that is present in the nums array, right? So here in this case, initial index. So this is index. Just give me a second. We are traversing from right to left. So indexing starts from 4. We have 5 elements, right? Indexing 0 index this is. So 43210. This is indexing. So nums we have here is, you can clearly see 41132. We have 41132. This one. Reverse again. 41132. So we are going with the reverse iteration, right? Initially, what we have to check for here, just give me a second here. Initially, what we have to check for, we have to check whether I plus nums of I greater than or equal to goal or not, right? Here in this case, I plus nums of I is it is already goal here. This one we can consider this is already goal, because we have to reach from 2 to 4, right? So this one 2 to 4 we have to reach. So this is already at the goal, so no change in this case. So we can just write here no change, right? So here in this case 3 and 1, nums of I here, I plus nums of I, nothing but I plus nums of I, 3 plus 1 here, 3 plus 1 here, 4. 4 is greater than or equal to goal or not? Yes, 4 is greater than or equal to goal in this case. So we will update the goal to 3 in this case, right? So if it is greater than or equal to goal, goal is 4 here. In this case, goal is 4 initially. So it is already at the goal, no change. So 3 plus 1, 4. 4 is greater than or equal to 4 we will consider here in this case. Yes, 4 is equal to 4, right? So then in this case, we will update this one to, update the goal to 3 in this case, right? So we will update the goal to 3. Then what we will do, we will again check for the I plus n plus I is greater than or equal to goal. This one will be 2 plus 1 here, 3. 3 is greater than or equal to 3 in this case, right? So we have updated the goal here. In this case, goal is 3. 3 is equal to 3. So now the goal will be, we will update the goal to 2 index. Now we will update the goal to 2 in this case, right? So this is fine. Next step is same thing, I plus n plus n, nothing but I plus nums of I is 3 here. This one will be 4 in this case, right? So 4 is greater than or equal to 2 we will check for. 4 is greater than or equal to 2. Yes, 4 is greater than 2. So we will update the goal to 1 here in this case, index 1, right? So in this case, the final step here is 2. We will consider 0 plus 2 here, nothing but 2. 2 is greater than or equal to 1. This one we will consider, right? Yes, 2 is greater than 1. So we will update the goal to 0, right? So now we can clearly see that we can move from index 3 to index 0 here, right? So since the goal moves back to index 0, since the goal moves back to index 0, we will return the output true here. Since here you can clearly see, since the goal moves back to index 0, we will return true as output, right? So here in this case, since goal moves back to index 0, we will return true. Again, I'm telling, we have successfully reached the last index. You can clearly see here, we have successfully reached the last index, right? So I hope this is completely clear. Since the goal moves back to index 0, we will return true in this case. Same goes with example 2 and example 3. You can try in the same way. So this is the approach that we'll be going with. I showed you with the first example. By considering the first example, step-by-step execution, you can just try it out for the example 2 and example 3 that they have given in the question, right? So let's discuss the edge cases very quickly, so that after discussing the edge cases, we can write the code and discuss the complexities of the code that we have written, right? So the first edge case here is single element array. So single element array, nums we have only one element, output will be true in this case, right? So it is already at the last index, only one element we have, it is already at the last index, we will return true in this case. So the second edge case here is large gaps with zeros preventing the movement. 3 to 1 0 4 we have, in this case false. We have already seen this one, we cannot go beyond 0, this index, so we cannot reach 4 at all at any cost, right? So we will return false in this case. So the third example here, third edge case here is array filled with a large jump. So here this one will be true because we can reach the end easily, right? We can just reach the end easily. 5 we have, 1 2 3 4 5, directly we can reach this one last index. So this itself, array filled with large jumps, output will be true. We can reach the end easily here. The final edge case here is array with 0 at the last index. Here you can clearly see the output will be true, right? So here we'll come one step and we can directly hop into 3 steps here directly. The fourth, this one. fourth edge case, right? So output will be true in this case. So these are the 4 edge cases that we need to keep in mind. Single element array, large gaps with 0 preventing movement, and the third edge case here is array filled with large jumps, and the fourth edge case here is array with 0 at the last index. I hope all the edge cases that we have discussed is completely clear, and this is the approach and this is the edge case that we need to keep in mind, right? I hope the approach and edge cases are completely clear. Now let's start writing the code. Let's start writing the code. Initially, the last index is always the goal, right? So let's initialize goal to here to the last index. Here in this case, length of the nums minus 1. So the next step here is let's traverse from the second last index to first index. We are doing the this one backward reverse iteration, right? So I'll just write here, so let I equals goal minus 1, I greater than or equal to 0, I minus. So this is fine. So if we can reach the goal from I, then we have to update the goal to I, right? Every step. So simple if condition here. We saw this one in the form of table, right? That I showed. If we can reach the goal from I, then we have to update the goal every step to I, right? So this I can write in this form. If I plus iterated value of nums is greater than or equal to goal, then what we will do, we will set the goal to I, or we will assign the goal to I. This is fine. The final step here is we will return the goal to 0. Means if goal is at index 0, then we will return 0. We have to check whether goal is at the index 0 or not, right? So I can just articulate this one in the form of code in this way. I'll just give here return goal. Let's check if it is equivalent to value 0, right? So from 3 to 0 we reached step by step reverse iteration in the table, if you remember that we discussed, right? From 3 to 0, finally we reached 0. That's what goal is equal to 0 or not, we will check finally. So that's what we will return. If it can reach 0, then only we will return true in that case, right? So else it will be false. So this is it for the code. Let's run the code. Let me hit the run button. So you can clearly see here the sample test cases are getting passed. So let me hit the submit button. So here you can clearly see all the test cases are getting passed here. Means the code works absolutely correct in this case. So let's quickly discuss the complexities of the code. Let's quickly discuss the complexities for the code that we have written. So the approach that we went with here is greedy. We know that one, right? So greedy approach we went with. So what will be the overall time complexity here? The overall time complexity would be big of n. Why? Because we are going with the single for loop, right? We are checking. We are iterating through the individual elements in the nums array, right? So here you can clearly see this one. And the overall space complexity would be here. In this case, it will be big of 1. Why? Because we are making use of only few variables. So here goal is the only thing that we are making use of here, right? So overall space complexity would be big of 1 in this case. So the time complexity would be big of n, and the space complexity here is big of 1, right? I hope this is clear. So I hope the solution that we have written is completely clear as well. For now, this is it. Thanks for watching.